Now that I have a file and auth server running, to be able to use it, I need it to talk to the network. First off, I'm talking to the file server right now using Drawterm. Drawterm is a program that runs on Linux and other Unix-like operating systems, Mac OS, Windows, and recently it was also ported to Haiku. It provides a kind of minimal Plan 9 environment. It does this by sort of providing devices for the monitor, which is represented as this window, the mouse and the keyboard, and combines that with CPU and storage of an actual Plan 9 system, or in my case, a 9-front system. And I'm also connected to the file server from the outside, not the internal network I configured when I did the installation. This video will cover basics of setting up a network connection. First off, you need some sort of networking hardware. This AU Star NAS box comes with 4 Ethernet ports. The install script already set up the first Ethernet port, Ether0, so I'm going to configure the second Ethernet port, which will be Ether1. Before the device is actually placed into a namespace, I can look at it through the special kernel device system. This will be a hash followed by some letters or numbers. In this case, it is a lowercase l and the number of the device, since this machine has more than one Ethernet port. I can go ahead and do an ls hash l1, and there's a directory in there called ether, just like the man page shows. And if I look at that, I can see that it shows a bunch of files. So just like the man page shows, the Ethernet device is presented as a directory with files in it. Once you have the networking hardware, you need a way of sending data out onto it. You need networking protocols. Plan 9 provides these as a kind of virtual device, and in the Plan 9 fashion, it also shows up as sort of a directory of files. It also appears as a kernel device, and in this case, it's hash with an uppercase I and a number, since it will be the second stack. So I can look at it with hash uppercase I1. And I can see that includes various stuff. So you have things like ICMP, that's the protocol for handling stuff like ping. You have TCP, UDP, and a variety of other options. Additionally, especially nowadays, you will want to handle encrypted traffic. This is also provided as a kernel device, and it is accessed with a hash and a lowercase a. Don't confuse this with audio, which is the uppercase a. It does not need to be numbered, since it isn't something bound to a particular piece of hardware. The last piece is handling DNS, or what would be covered by an etc hosts file on old Unix systems. You need a way of turning human-readable words into IP addresses and back again. This is handled by the network database, or NDB for short. The files are typically stored in libndb. There is a common file for common stuff. So in here you'll find things like ways to convert protocol names into various port numbers. For the local network, there's a file called local. At the top we can see that there's stuff, that it also pulls in from common and other files you may need. And then farther down is where you list the configurations for your particular network. So here you can list out the systems that are on the grid, what IP addresses they should have, your DNS servers, your auth and file servers, and that sort of stuff. So section 8 of the man pages has a page for the programs that use the network database. The two needed for setting up a network interfaces are CS, or the connection server, and DNS. As the name says, DNS is used for dealing with domain name servers. The connection server is what Plan 9 uses to read the network database and translate all that back to the system. It is what the libc dial function uses to turn system and port names into numbers and to set the address of the DNS server you want to use. When these programs are run, they also present themselves as files that can be mounted in the network directory. When setting up a network device, you use the IP config program. This can be used to select which device to configure by listing the device type and directory that the files for the network device are found in. If no IP address is specified, we'll use DHCP. And at the bottom of the man page here, you can actually see examples of how this can be done. So here's the example of the second network connection I made to the outside world on my 9front server. The net alt directory is already provided on the file system as a place to build alternate networks. It just shows up normally as an empty directory. So I add the Ethernet device, protocol stack, and the TLS device. Then I run ipconfig to set that device up. After that, I run CNS or CS and DNS. And these last three commands here, they all have a part where I specify that I'm using the net.alt directory. By default, most programs check the net directory, and I also have a alternate NDB file for talking to the outside world. It has IP addresses suitable for communicating with that network. And since these changes are only seen in this process, so at the start I ran rfork to split off a separate process. When I get to the end here, and I'm running listen, I need it to be able to see this new network I built in the net.alt directory. The way I do that is I specify it to use the special namespace recipe I made. So I can look at that here. And in it, I tell it to mount this serve net into net alt. And that's what this thing here makes. It basically takes what I've put into net alt, package it up, and post a file descriptor to it in the serve directory as net1. So at that point, I can then have the listen command run and actually be able to see that network and respond to connections that come in on it. With all this done, I now have two Ethernet ports connected to separate networks. In other operating systems, running multiple network connections can be troublesome. They typically use a global namespace, and every program can see every networking device. In Plan 9, programs are written to check /net by default, and often they can be told to use different network stacks. And this can also be handled by changing what is in the /net directory of a particular window, and any program ran there will use that by default. So I can kind of demonstrate that quickly here. So this window here has the default namespace with the /net that was configured with the at install. So it has ether device 0 in it. Over here in this window, I went and mounted that net1 over net. So over here, when I just look at /net, it shows ether 1. So the first one is just the purely internal network. It has no connection to the outside world. So if I try to ping Google, it'll just sit there not being able to do it. But on this one, pings go out to the outside world, hit Google, and come back. So an interesting effect of this is that you don't need to run a network address translation system like a typical home Wi-Fi router does for you. Since this outside-facing network stack is just a collection of files, it can be shared across the network and mounted into the namespace of another computer. While it is possible to set up a NAT-like system, and I'll include a link to a video in the description where I did that, it isn't required, and in some cases might not be wanted. Later I'll be adding various IoT devices to the grid, and I may not want them to have access to the outside world. So by treating the outside connection as a sort of disembodied device, available on the grid when asked for, I can make sure that only machines, users, or processes with authorization can access that port to the outside world. Finally, if you're doing this and run into trouble, the first step is to run a script called net audit. This will run through all your settings and complain if it sees something wrong. So in this case, my internal network can't actually ping the DNS server. So if I'm having issues, I can see that that's a known problem to it. This is very handy, as a bug often just results in, no connection at all. So this will help you narrow down where the problem may lie. And as always, have fun.